So in this video, we're going to look at the post-lab questions, and I'm going to talk you through how to do the calculations within the post-lab questions. So question 1, we've already looked at in class. So part A just asks what type of chemical reaction is taking place. So if you take a look at the Fe plus CuCl2, just think about which one of the 5 types of reactions that looks most like. And then for B, you had to write the 2 possible equations. So we did these 2 on the board. So your 2 possible oxidation states of iron is +2 or +3. So you're writing this first equation as if iron was +2. You're going to write the second equation with your products as if iron was +3. So you're going to have FeCl2 because of crossing charges plus Cu. You're going to have FeCl3 because of crossing charges plus Cu. Formula of your iron product is just either FeCl2 or FeCl3. So for questions 2 and 3, it's asking for molar masses. You're just looking at the periodic table for the molar mass of iron and the molar mass of copper. Remember, molar mass is just for 1 mole, so you're just going to look right off the periodic table and find the mass of 1 mole. Now for questions 4 on, this is going to actually be using your data. So what I did up here at the top is I took a group's data, and I'm going to be using this data as I go through and calculate the different variables that the lab is asking for. So for number 4, it says to calculate the mass of iron that reacted. And it says to remember, not all of the iron you started with reacted. So if you think about where the iron came from, right, we're just trying to figure out the mass of iron. So we're looking at grams. So if I look up at my data table, all of the iron came from the nails. So if this is how much iron I started with, this is how much iron I ended with. So these are the iron nails before, the iron nails after. The mass of iron that reacted must be the difference between these two. So what we're going to do, I'll just do all the problems on a separate piece of paper, is I'm going to take the mass of the nail before minus the mass of the nail after. Now, make it a positive number, so if you notice that your number is negative, then just make it positive. Right? So think about like the absolute value. Just because you can't have a negative mass, that just means source of error, right? So that's how we're going to find the mass of the nail that reacted. So then question 5 says calculate the moles of iron that reacted. So all we're going to be doing in question 5 is we're going to be taking our value from question 4. So I'm just going to put my grams here. We're just going to take our value from question 4 and just go to moles. So think about how we go from grams to moles. If it's moles of iron, I should make sure I label, this is going to be the molar mass. So look at the periodic table, right, figure out what your molar mass of iron is. That's actually what you calculated in number 2. So if you do your grams divided by the molar mass, that's going to give you moles of iron. Okay. So then question 6 says calculate the mass of solid copper made in the reaction. This is called the actual yield because it's what was actually obtained. So if I look up at my data table again, here's just my empty beaker. So this is the mass of just the beaker. This is the mass of the beaker with the solid copper. So if this is the beaker with the copper, this is just the beaker, we can subtract these 2 values to get just the copper. So for question 6, I'll do beaker with copper minus empty beaker. And you're going to find that you're probably going to have relatively small numbers. You're not going to have like 25, 50 grams. So that's going to give you your mass of copper. So again, let's look back at the questions. Now question 7 says calculate the moles of copper. So like before, we're going to take our grams from number 6, and we're going to go to moles. So just like we've been doing, use the molar mass. Molar mass is for 1 mole. You found the molar mass of copper in question 3. And then you're just going to divide. That's going to give you moles of Cu. Okay, so once we have our moles of copper, we can look down at question 8. So it says you need to use your data to determine if iron has a +2 or +3 charge. Express a simple mole ratio from your data. And it tells you right here how to do it. You're just going to do moles of copper divided by moles of iron. So I'm going to take my moles of copper from number 7, and I'm going to divide by my moles of iron from number 5. So you're probably going to get some decimal, but that's fine. That's what we want. So once we have our mole ratio in number 8, we can go on to number 9. Number 9 says to look at the coefficients from number 1. So up here in the balanced equations, this is going to tell us our mole ratios because it's going to be different if it's iron 2 or iron 3. So what we're going to do down here is we're going to look at our mole ratio if it's iron 2+ or iron 3+. So again, you're going to do moles of copper. So you're going to look at your balanced equation and you're going to do Cu divided by Fe for both of them. One of them should be 1, one of them should be 1.5. You can figure out which one is which. Right? And then the rest of question 9 says which one of these ratios best fits with your data. So you're going to look at what you got in number 8, and you're going to figure out, is what number you got in number 8 closer to 1 or 1.5? If it's closer to 1, it's going to be iron 2. If it's closer to 1.5, it's going to be iron 3. Right? Now your data might be different from another group's. And if your data is different from another group's, that's totally fine. Right? It's lab. Sources of error happen. So question 10 is just a stoich question. So you're starting with 2.5 grams of iron and you're going to moles of copper. Use your balanced equation that best matches your data. So if you had iron 3, use the iron 3 equation. If you had iron 2, use the iron 2 equation. Right, so this is just a stoich question. And then 11 is asking you to look at sources of error. So think about, is your mass of copper going to be too high or too low? And look back at your calculations and see how that might affect everything. And then you're just going to write your conclusion. And it tells you, again, what you need to make sure to include in your conclusion.